Hey y'all, Miss Michelson here. Today I'm filming a video going over the topic 5 review for Advanced Algebra 2. So I've got that pulled up on my screen. I've also got my Desmos tab already loaded up because I know I might need it. And let's go ahead and get started. So the first question is asking me to simplify the given expression. It's got a radical, it's got exponents in it. We can solve this by hand, but we could also use our calculator. The one thing we got to remember is in our order of operations, that's in the way. In our order of operations, we want to take care of these parentheses first. So a negative number squared is going to spit back a positive. So I'm taking the square root of positive 81, and I know that that equals 9. So I'm going to go ahead and type in my box here that it equals 9. And then we are good to go ahead and start on the next question. I've got this new little tablet thingy, and I forgot how it worked already. Our next one is asking me to find the fifth root of -1. Now, this is a kind of a weird one because I got the number 1. However, I've seen lots of larger numbers on this one as well. I may know what the fifth root of -1 is, but maybe not one of those larger numbers. This is one you can solve using your power card, or you can type this in on Desmos. So I want to show you the graphing calculator. I want this to go away because I don't need it. Put it over there. If you type or hit this button down here, the keypad, it gives me all of the functions of a graphing calculator. And if I go over here to this functions button and I scroll all the way down, this nth root button, it gives me a place to type that 5 in. So I could take the fifth root of -1, which is -1. But I've also seen like -243 be up there. And I know that that answer is 3. So if you don't know these, if you don't have your power card nearby, just use the graphing calculator. My answer is going to be -1. All right, moving on to our next one, simplify the radical. I'm taking the fifth root. Oh, here's my -243. X to the 10th power, y to the 5th. In our notes, I had been splitting these up into kind of 3 separate problems, one with just the number, and then one with each of my variables. So x to the 10th and the fifth root of y to the 5th. So lucky I chose that number. But I know that I could simplify this with my power card, or I just saw it on Desmos. The fifth root of -243 is -3. The fifth root of x to the 10th power, you can ask yourself, how many times does 5 divide 10? And we would get that to be x squared, or you can think of that as that fractional exponent 10 over 5, and that reduces to give me my power of 2. And this one over here, how many times does 5 go into 5? It goes in 1 time, so I have y to the first power, or you can think of that as y as 5 divided by 5. So this is going to be my answer I type into my box. -3 x squared y. And I'm not going to put to the first power there because I don't necessarily need it. Moving right along, our next one is going to be our multiplication problem. Now, this one, if we look at it, doesn't have any numbers. We just have variables in here, but the process is still going to be the same, and our radicals are still going to behave the same way. So this is a double distributing problem. I have to take radical k times radical k, and I know that that's going to reduce to k. K times a is positive, so that's going to be positive a radical k. Negative a times radical k is minus a radical k. And negative a times positive a is negative a squared. So this pattern is always going to stay true if we're multiplying something by itself or its conjugate. And we can see that our middle terms here are going to cancel each other out. All I'm left with is k, not plus, k minus a squared. And that's going to be my answer. K minus a squared. Just be careful with the variables you're typing in. I've seen so many people get something wrong because they typed in a x instead of a y or an r instead of a t, all of those fun things. So we did a multiplication problem, and so our next one's going to be a division problem. We talked about in class how our division problems are just kind of a double multiplication problem. We want to rationalize the denominator, which means we got to get rid of that radical 5. And the way we get rid of our radicals is by multiplying by the conjugate. So whatever I multiply in the bottom, I have to multiply throughout the top. The numerator here is nice because I'm just distributing that 7. So Savas sometimes writes their final answer like this, 7 in parentheses, 1 minus radical 5. You also could just distribute that 7 minus 7 radical 5. Either or, they also accept that as the correct answer. Now, for the denominator, we have to double distribute again, but in the back of our mind, we're thinking, how can we get rid of our radical? Or we should see our radical go away. So I'm going to do 1 times 1, which is 1. 1 times negative radical 5, which is negative radical 5. Positive radical 5 times 1 is plus radical 5. And then radical 5 times radical 5 is just 5. And plus times a minus is a minus 5. So my middle two terms cancel out, all of my radicals disappear, and I'm left with 1 minus 5 or 4. Ooh, negative 4. Let's be careful with that. And that's what I'm going to type into my answer box. 7 minus 7 radical 5 divided by negative 4. And I just put parentheses around the top because I forgot to put the fraction button in first. Next one are transformations of our radical functions. This is one that has that little bit of an extra step so that we can identify the transformations nicely. So we're given the equation, or at least my equation, is the square root of 36x minus 36 minus 2 on the outside. And we traditionally want to see this written as a times x minus h plus k. So the big notice or the big difference here is that there's no value in front of this x. So we want to somehow find a way to get rid of this 36. And our numbers here will always be nice. So I notice that underneath my parenthesis, there is a common factor of 36. So I'm going to undo my distributive process and take that 36 away from both of those terms. So I'll be left with 36 and x minus 1 underneath of my radical. Now my properties of radicals tell me if I have multiplication going on, which I do here, that I can give those terms their own separate radical. And I know what the square root of 36 is. That equals 6. So I can simplify this term and bring it on the outside of my radical, and I get a 6 because the square root of 36 is 6. The square root of x minus 1 does not simplify. So I'm going to leave x minus 1 underneath my radical, and my minus 2 just stays on the outside. This is my simplified expression. 6 times x minus 1 minus 2. And then the last thing we want to do is just answer what these numbers are actually doing to our equation. So I'll get rid of all of my work. And now we're just going to describe what do these values do. So my A value is 6, and I know that that's going to stretch me by a factor of 6. My H value is negative 1, and I know negatives move me to the right 1 unit. And my K value moves me up or down. It's negative, so it's down 2 units. I like to answer this word first before I fill in the numbers. But maybe I'm backwards with that. I don't know. This one is a little funky just because there's a lot of words on the screen. But our basic gist that we want to be able to take away from this problem is if we can find the domain and range of our original function, domain and range, then we should be able to easily state the domain and range of our inverse function. We talked about in class how we just switch them. The domain of one is the range of the other, and the range of one is the domain of the other. So how can I find the domain and range looking at this equation right here? My best guess is just to graph it so I can figure out what this function looks like. So I'm going to come over to Desmos and I'm going to graph the square root of 2x, was it minus 3, I think? And I noticed that it has a y, not a y, it has an x-intercept right here. And that's going to be kind of my main point. Because if I'm thinking about the domain of this function, I'm thinking from left to right. It goes from 1.5 all the way to positive infinity. So if I go back over here, my domain was 1.5 to infinity. My range was 0 to infinity. So what we wanted to do is take that information and find the range of the inverse function. So I know the domain becomes the range. The range of our inverse function is 1.5 to infinity. Now, the way we're going to answer this is read which one of these sentences is actually correct. The range of the inverse is same as the range of f of x, not true. The ranges don't stay the same. The range of the inverse is the same as the domain of f of x. That one is true. So that's the box that I'm going to type in. And it's weird to figure out what it's asking, but it's asking me for the domain of f of x, which is what we answered here. But it wants it as an inequality instead of an interval. So I'm going to say x is greater than or equal to 1.5. Yes. Okay. So our next one is just graphing the function. You can use Desmos here to graph, or you can use what we know about transformations. The question I'm asking myself is, what is that negative 6 going to do to my parent function? I know it's going to move it down 6. The shape of my graph is going to stay the same. I know it won't be A. I know it won't be D. B has moved to the right 6. C has moved down 6. Oh, I think I have to answer the domain and range. Continue. Weird. Or not. That was weird. Now we're getting into a word problem. I'll move my face to be in the right spot. It says a formula is used in the medical field to estimate a person's body surface area. The formula is A equals the square root of H times W divided by 60, where A is the body surface area in square meters, H is the height, and C is the weight in kilograms. So we're having two different problems here. Part A says compute the body surface area of a person who is 171 centimeters tall and is 92.8 kilograms. So we're given the H and the W. So all we have to do is plug in A equals the square root of 171 times 92.8 divided by 60. That is something that I would type all into my calculator. Over here, the square root of 171 times 92.8 divided by 60. Let me check my numbers. 92.8. It says to round to the nearest hundredth. So that's 2 decimal places. So that 9 is going to bump that up to a 10. So I think it's going to be 2.1 square meters. All right, so the second question, we're given if the woman is 168 centimeters tall, that's the height, and has a surface area of 1.71, that's A, how much does she weigh? So now we're going to use our formula and we're going to say 1.71 equals the square root of 168 times W equals 60. So we're going to have to do a little bit more algebra. We can't just plug and chug. We got to get W by itself. The first thing is that it's being divided by 60. So I'm going to multiply both sides by 60. That's going to cancel this out here. So 60 times 1.71 is 102.6 equals the square root of 168W. I want to square both sides to get rid of my radical sign. And I get 10,526.76 equals 168W. And then I'm going to divide both sides by 168. And I'm going to get W equals 62.659. But this time it says round to the nearest tenth. That caught me the first time I was doing this. This is going to be 6.27. So what my answer is going to be? 6 point, oh, not 6.27, 62.7. There we go. Word problem, not that bad. Lots of numbers though that we're dealing with. Our next one is another multiplying problem. And I will clear my screen. There's got to be a better way to do this, but I don't see one, so this is what I've got going for me. This one says multiply and then simplify if possible. So we're just going to distribute this -6. -6, that's radical 6. Remember that when you multiply radicals, you just multiply the numbers underneath of them. So I'm going to have radical 42. Radical 6 times radical 11 is radical 66. And it says write your answer using radicals, like an exact answer. So I know that I have multiple attempts here. I'm going to check to see if they'll accept this as my answer, and they will. I don't think that any of my perfect squares divide 66 or 42, so those are simplified radicals, which is why I was allowed to leave that as my final answer. Number 11, these are my favorite questions. We are finding the composition of our functions. Notice our notation here that says f of g of x. We're finding f of g of x. So that means we're starting with our f of x function, x squared plus 3. But wherever we see an x, we are going to replace it with g of x. So this x gets replaced with all of my g of x function. So that means it's going to be 5x squared plus 3. 5x squared is 25x squared plus 3 doesn't change, so it just comes down. My answer here is 25x squared plus 3. My second part of this question is asking me to find g of f of x, which means we're starting with our g of x function this time, f of x, 5x. Wherever we see an x, we are going to replace it with our f of x function. So f of x gets to go in for x. So we're turning that into x squared plus 3, which means this is 5x squared plus 15. 5x squared plus 15. Next question, find the inverse of the function. La-di-da-di-da-di-da. The inverse of our function, we had 3 steps. The first one is just a formality. I like to think of our inverses in terms of x and y. So I'm going to rewrite my equation as y equals 5x plus 9. Our second step is to switch the location of x and y. So this is going to turn into x equals 5y plus 9. And then our final step is to get y by itself. We subtract 9 from both sides. X minus 9 equals 5y. And then we divide both sides by 5. Savas will accept this as your final answer, or you could write it as 1/5 x minus 9/5, but that takes a lot of time to type in. So I'm just going to go with the x minus 9 divided by 5. Number 13 is determining whether or not a number provided to us is the solution. So what we want to do is we want to take this number here, -8, and we want to plug it in for x into our equations wherever we see it. And then we're going to make a judgment based on what we find. So this x right here is going to turn into negative 8. 4 times negative 8 plus 57. And then this x right here is going to turn into negative 8 plus 13. 4 times negative 8 is negative 32. Negative 32 plus 57 is 25. So that's the square root of 25 equals negative 8 plus 13 is 5. And then we can simplify here. The square root of 25 is 5. 5 equals 5. This is true. So this is just plugging in numbers and simplifying. Oops. Oh no. Our next one, another word problem. Not too bad. We are given a formula for velocity. V equals the square root of 2gh. This is bringing me back to my physics days, my favorite class that I took in high school and in college. So this equation models the velocity in feet per second of an object that is falling from a height h and it's being accelerated by gravity. So it's like a dropped object. We know g is 32 feet per second squared. So I'm going to plug that into my equation. I know g is 32. And it's going to ask me how far will an object fall if it has a velocity of 24 feet per second. So we're solving for h if we're given our velocity is 24. So all we have to do is undo all of these operations to get h by itself. Right now I see that it's trapped underneath of a radical. So I got to get rid of my radical by squaring both sides. 24 squared is not something that I know, but I can find it out. 576. My radical and my square are going to go away. And I'm also going to multiply these together right now. 32 times 2 is 64. H. Divide both sides by 64. H equals 9. So that means the starting height of my object that I dropped had an initial height, or it falls 9 feet to reach that velocity of 24 feet per second. Oops. And we are almost done. I think we have a couple more word problems though. Number 15. Solve the equation with rational exponents. So we had a way to get rid of this rational exponent. But the first thing we want to do is move this constant term to the other side of my equation. I would prefer this part of my expression to be isolated. So I'm going to add 6 to both sides, and that's going to give me 27. And the way I'm going to get rid of this rational exponent is by applying the reciprocal or the inverse. If I raise this to the 4/3 power, that's going to be 4 times 3 is 12 divided by 4 times 3 is 12. Those are going to cancel out. But what I do to one side of my equation, I have to do to the other. And I don't know what this is off the top of my head. I could do some like manipulation there and use my power card, but I also can do this in Desmos. 27 to the 4/3 is 81. And that's the cube root of 27 is 3. 3 to the 4th power is 81. So it makes sense. So what I've got going on here now is x squared minus x minus 51. These cancel out. So all I'm left with is this guy over here equals 81. And I'm going to subtract 81 from both sides. X squared minus x minus negative 51 minus 81 minus 132 equals 0. Once I have a 0 in there, I'm ready to factor. I know that my factors, one's going to be positive, one's going to be negative to get that negative 32. And I want them to add up to that middle term of negative 1. So I'm looking for factors of negative 132 that add up to 1. If their sum is 1, that means that the two numbers are one number apart. So like 11 and 12, 9 and 10, 13 and 14. I'm trying to find one of those pairs. That's going to give me 132. And this is just some guessing and checking. 132 divided by 9. 132 divided by 11. And once I do some guess and check in my calculator, I can find my factor pair are 11 and 12. And if if this number down here is negative, the bigger number is negative. So I'm going to have a positive 11 and a negative 12. I'm going to split those up. X plus 11 equals 0, or x equals negative 11. X minus 12 equals 0, or x equals positive 12. And these are my two solutions to my equation, negative 11 and 12. Almost done. We've got a word problem, and then we got the 12-step problem, and then we are ready for our test. So this one is kind of like an analytical problem. We got to think a little bit about the math. We don't have to do too much computation, but we got to think a little bit about the math. So it says the regular price of a computer is X dollars, and we have these two equations right here. We kind of want to interpret what they mean. So it says, describe what the functions f and g model in terms of price of the computer. So function f is x minus 280. What is that going to represent? And I've got a drop-down box, so I've got options. Is it a 208% discount? Is it a $280 discount? Or is it $280 of sales tax? So if it was tax, it would be additional. I would see a charge of plus $280. A discount of percentage-wise is always going to be multiplication. So 10% is like 0.10 of a number. But a $280 discount is just going to be subtracted from your total. So I'm thinking that one is a $280 discount. Now, my second equation is 0.6x. So let's look at our options here. Is this a $60 discount? Nope, that would just be a minus 60. Is this a 40% discount or a 60% discount? So let's think what we're doing here. We're doing multiplication. We're taking 0.6 of our price, which means we're taking 60% of it, which means we're having a 40% discount on computer. F of g of x, we want to find f of g of x, and then we're going to describe what that means. So we're using our function f of x, and that is x minus 280. But instead of x, we're going to replace it with g of x, which means we're going to do 0.6x minus 280. Remember, anytime I substitute in a value, I'm going to put parentheses around it. So my answer here is going to be 0.6x minus 280. And now we want to describe what's happening here. And this is the reason why I put our parentheses here, so we could remember our orders of operations. We want to say the order in which these discounts were applied. Is it first the 40% discount and then $280 off? Or do we do the $280 first and then a 40% discount? Well, we know parentheses is where we start. Also, multiplication comes before addition and subtraction. So it's first a 40% discount and then $280 off. Our next question is the same thing, but now it wants us to find g of f of x. So we're starting with our g of x function, 0.6x, but wherever we see an x, we're going to replace it with f of x, which means we got 0.6 times x minus 280. Now, I'm not sure if they're going to want me to simplify this, so I'm going to just check first if I could just type this in. And I think they should let me. Yeah. So now what are we doing first? Well, look, x minus 280 is stuck in our parentheses. That's the first operation that has to go on when we're talking about simplifying that problem. So our $280 discount is applied first, and then we're taking 40% off of that. And then the last thing we want to do is describe which one gives us a better deal. Subtracting 280 and then doing a $40 discount, or doing the $40 discount first and then subtracting 280. So what we can do here is we can test a price of our our computer. So let's do this equation right here that we found for B. And let's say my computer was $100. That would be 0.6 times 100. Oh, it's got to be bigger than 280. Let's say my computer was $500 minus 280. So 0.6 of 500 is 300 minus 280 equals $20. So using our f of g of x function, my price of my $500 computer after all my discounts is $20. Now let's do the same thing with our g of f of x. 0.6 times 500 minus 280. We'll do that one first. That's going to give me 220, and I'm trying to find 0.6 of 220. 0.6 times 220, this equals $132. So my f of g of x function is going to be the better price. F of g of x, since the $40 discount is taken off the regular price first. All right. Okay, last one. We are solving for our value of x. Remember we talked about in class that this is going to be a multiple choice question on the test. You can always plug and chug your answers in and see which one is correct. But if you are anything like me and you like algebra, then we can work through this problem. The first thing we want to do is isolate a radical, which means I want to get one radical all by itself. So I'm going to pick x plus 32, and I'm going to isolate that one. That one's my favorite. So I'm going to move this one to this side of my equation. 9 minus radical x minus 13. Beautiful. We've isolated this radical over here. That's my target. What we want to do is get rid of this radical by applying my inverse. Applying my inverse means I square both sides. And what that's going to leave me with, I'm going to come up over here. I'm going to get rid of the radical on my left side of my equation, but my right side of my equation, remember when we square something, it means we're multiplying it by itself. So, we've got to take, I'm moving myself down here. We've got to take 9 minus the square root of x minus 13 and multiply it by itself. What we now have to do is some double distributing. 9 times 9 is, that's about color. 9 times 9 is 81. 9 times negative x minus 13, radical x minus 13 is this. Negative radical x minus 13 times 9 is minus 9. X radical x minus 13. And radical times the radical gets rid of the radical. Negative times a negative is a positive x minus 13. And that equals x plus 32. So we distribute. Now we got to clean this up. I see some like terms that I can add together. 81 minus 13 is 68. Negative 9 radical x minus 13 minus 9 x radical 13 is negative 18 x minus 13. So I added those together. I did those. And then my plus x. has nothing to go with. That equals x plus 32. Now I want to isolate this radical over here. It's my next target. So I've got to move some of these terms over by subtracting x from both sides. And my x cancel each other out. We're happy about that. I'm left with 32 equals 68 minus 18 square root x minus 13. I want to get my 68 to the other side, so I'm going to subtract 68 from both sides. And that's going to give me, I feel like I should know this, negative 36 equals negative 18 square root of x minus 13. And then the last number on the same side of my radical is this 18. So I'm going to divide both sides by negative 18. Boop. Cancel each other out. We're left with x minus 13. Negative 36 divided by negative 18 is 2. And now we've got a radical equation. We've got our radical isolated on my right side. I got it equal to a number. This one's not going to be half so bad. I'm going to square both sides to get rid of my radical. What I'm going to be left with, 2 squared is 4. I'm left with x minus 13. And then I'm going to add 13 to both sides. X equals 17. And that's my final answer. Technically, I should plug it back in and check to see if it works. I should do that. But I'm going to check to see if it's the correct answer. And it is. So that's going to be the end of our video. I believe that's our last question. If you have any questions for me, please let me know. And I will see you all on Thursday when we take our test.